This video is a quick look at the differential equation facilities in autograph, and in particular the first order linear equation. So here it is, been entered as y prime plus y equals x, and it all looks very neat and tidy. So how do we get that? Double click. The startup options are the thing to go for, and you can see that it can either be at a point or manual. In other words, it takes solutions where you click, or a set of points, and that's what we've chosen here. And the set of points are along the y-axis. You could choose the x-axis, or you can have a particular start line from somewhere to somewhere. So that's how that works, and let's just click OK. So we'll take it back now, just to Control A and delete, take it back to the start and see how it all works. So let's enter y prime equals 0. And what have we got there? Well, of course, it means that wherever you click, it's going to have a 0 gradient. Let's do y prime equals 1, and trivially it's the same concept, except this time it's at 45 degrees. Or it would be if we had equal aspect. That's better. Now let's extend it and put in x here instead. And what does that mean? That means that the gradient is equal to how far it is from the y-axis. So it's going to be 0 all the way down here, and as you go to the right it gets steeper, as you go to the left it gets steeper negatively. Okay, so that's why it ends up as parabolas. Now it's beginning to look a bit of a mess, so double click, we'll do the startup options, point set and y-axis. Okay, okay. And now we have a set of parabolas. The answer, of course, is a half x squared plus a constant, so let's put that in as well. Y equals 1/2, there's a half here, xx for x squared plus c. Now c will be 1 to start with, so it's going to be this one here. Should be coming down here, where it comes. Yep. So what are all the other ones? Well, if we use the constant controller, you can see that by making the step 1, you can just march up and down the same solutions. Now, drawing parabolas that are separated vertically isn't always a natural thing to do for a lot of students. So if we just put a point on here and then right click, do a vector of 0, 1, you can see that it is indeed the vertical displacement. Okay, let's delete that, and let's delete the equation. And on we go. Let's take y prime equals y this time. Now, it may have only been last week that you were teaching the exponential function, for which one of the definitions is a function which equals its own derivative. So this should be lots of exponentials, but let's see what we actually get. Well, there's no doubt about it. This one is y equals e to the x. Let's try that. Y equals e to the power of x. Indeed it is. What are all the other ones? And there's quite a bit to discuss here. You might think it's e to the x plus c. Well, it clearly isn't. And of course you can put the constants in lots of places. You can put it here, or x plus c in the exponent, but not plus c down here. And that will indeed enable you to get all the solutions. So, if we're talking about a practical situation, anything which extends like this up to infinity is not really a very useful solution. So let's have a look at y prime equals minus y. That should be exponential decays, indeed it is. Now this is the starting blocks of the linear differential equation, because if we rearrange this as y prime plus y equals 0, we also get this exactly the same thing, of course, exponential decays, ending up with a steady state of 0. So the suggestion now is that if we make that 1, it will end up as a steady state of 1. And if we make it x, well, you know from the teaching of this that you've got to put in ax plus b at this point, because it can be differentiated once, and you find that y is equal to x minus 1, which is this straight line down here. But we could play around with this a little bit more and have a constant here, for example. Let's do m. M is going to be 1, but what it does mean is if you play around with m, you could, for example, make m a bit smaller. We have got a dynamic object here, and if m is 0, we're back to parabolas again. And this is where we came in, so I hope you found that useful.